Well, hi there, everybody, and welcome to Slooh, your interface to outer space. I'm Jerry Moulton. I'm your host. And tonight we have a very special show. We are keeping tabs tonight on the Delta Aquariid Meteor Shower. Now, we're going to be live for about 4 hours, watching and learning all about meteors. Over the course of this show, we'll have segments from all of our community perspectives. We'll discuss why scientists love meteor showers, the different ways that you can see and hear them, and we'll watch the skies with our telescopes. Excuse me. And speaking of telescopes, let's welcome in our friend and colleague, Slooh astronomer Paul Cox, who somehow managed to weasel his way through customs and is in the United States. And in fact, I understand in the same time zone as I am for perhaps the first time ever on Slooh. I don't know why that matters, but it's a fact. Paul, welcome.
Well, it means we're at the same kind of stage of tiredness tonight, Jerry. So, usually when you're speaking to me, it's about 5 a.m. in the morning in the UK or something. So, yeah, we're in the same time zone tonight, which is really good.
And we're on equal footing. Okay, here we go. So I assume, Paul, we have a number of feeds tonight?
We do indeed. And what we're looking at here actually is our nighttime panorama of Slooh's Observatory in the Canary Islands at the Institute of Astrophysics of the Canary Islands. And actually just down there in the bottom left, you can see one of the enormous domes. That's one of the largest asteroid monitoring and space junk monitoring telescopes in the world. That one's pretty cool. And this is where the Slooh telescopes are based, that Slooh members control every night. But this is just a panorama, and this is just actually showing us something that we're going to talk about a little bit more when we see the other feeds. Looks a bit hazy there. Regular viewers will know that we normally see stars popping out in this image, all across the image. But if we take a look at our all-sky camera and the other feeds that we've got tonight, here we can see it a little bit better. Now, this is our special low-light camera that looks 180 degrees across the sky. So down in the bottom left, that's east, the right is west, top is north, bottom is south. And we can see actually there, the light that you see there, that little red light, isn't our first meteor of the night. That's actually a light on the half-meter telescope. That's a big dome that's in, because we're kind of looking at it sideways. And it's in a big clamshell dome. That's the half-meter telescope. That's looking at loads of deep sky objects tonight, galaxies, nebulae, all sorts of things Slooh members are pointing them to. But actually for meteor showers, you don't need a telescope. You need these wide fields of view. So here we've got this all-sky camera. You can see this haze, and this yellow haze is actually dust from the Sahara Desert, which has kind of been blowing over the Canary Islands. The Canary Islands are only about 300 miles off the west coast of Africa. So we've been suffering a bit of haze lately, but it's still good enough to see the Milky Way. So what looks like cloud stretching up through the image, you can see some delicious color in there, actually. That is the Milky Way, our galaxy edge on. And in fact, at the bottom of that image, we're actually looking at the very center of our galaxy, which is pretty cool. But Jerry, the important thing is, if we can see the Milky Way, it means we will see meteors. So the conditions are good enough, because the biggest problem with meteor watching is not having the moon in the sky. Moonlight will kill meteors immediately. But we've also got some other great cameras as well. We've got our constellation cam. Now, this is actually going to be my favorite of the night, because this has a huge field of view. This is kind of piggybacked. It's attached to the top of a new telescope that we launched last week, the new Canary 3 Deep Sky Telescope. And both of these instruments give these enormous wide fields of view. This is about 20 degrees across. So we're looking at a huge swathe of sky, which increases the chances of catching one of these Delta Aquariids. We've also got, now in that view, by the way, they're going to appear as a streak, and we should see it for maybe a minute or so, because this is taking a very long exposure and then streaming that image to what we're seeing. But we also have a live video view as well. This is a special low light camera, and it's our Meteor Cam, and it's the camera that gave us some superb shots of the Perseid meteors last August, I think it was. Actually the best meteor shower we've ever seen at Slooh. Now, this doesn't give the clearest view of the stars. All of those things that we're seeing there are different color stars because of the way the camera works. But what it does enable us to do is see a meteor as it whizzes through the sky. and I think we're going to hear from our experts a little bit later. One of the things with the Delta Aquariid meteors is that they can leave what's called a persistent trail. So this is ionized gas that they leave behind, and that can actually stay in the sky illuminated, maybe for about 30 seconds after the meteor has whizzed through. So that's something to keep an eye open for in this meteor cam. But Jerry, it's not just the Canary Islands night. We've also got some partners around the world. Now, one of the best places at the moment in the hours of darkness is kind of in mid to Western Europe. So we've got Frippon. Frippon is the Fireball Recovery and Interplanetary Observation Network. Try saying that at 5 a.m. in the morning, and it's a lot more difficult. Now, this is going to give us some great views. These guys have got cameras, all sky cameras, very similar to ours, but they're in black and white, and they've got them all over France and other countries in Europe. So those are going to be providing some pretty cool views as well. And the team at Slooh HQ, they're going to be keeping an eye on all of those feeds, and they're going to be showing us those if we catch any meteors. We've also got, it's a high altitude observatory in France. It's called the Pic du Midi Observatory. And this is way on top of a mountain. It's an incredible observatory. It's kind of stuck on top of these rocks. But here we can see their all-sky camera. And once again, the Milky Way stretching across the sky.
Wow.
But once again, in this image, if we catch any meteors, they're going to appear as a long line, probably a little bit thicker at one end, a little bit thinner at the other. And then we've gone to a new partner tonight in Slovenia. And this is the Crni Vrh Observatory in Slovenia. And I'm quite hopeful on this one because this is further east. Now, like most meteor showers, the Delta Aquariids are best seen in the hours before dawn. And of course, it's midnight now in the Canary Islands. Now, these guys are far further east. So I suspect it's probably about 3 a.m., maybe even 4 a.m. there. So keep an eye on this one because once again, we should manage to catch some streaking meteors in that one.
All right, Paul, fantastic. And what kind of activity, how many meteors do you think we're going to see tonight, say on an hourly basis?
Well, you'll hear all sorts of figures for the Delta Aquariids. Now, what's called the hourly zenithal rate, these are under ideal conditions if, we're going to hear about this a little bit later on, but if where these meteors appear to come from, the radiant, was right above us on a perfectly clear sky, you would expect to see between 15 and 20 meteors per hour. We were talking before the show, if you look at the athletics team of meteor showers, this guy is the marathon runner. It doesn't have a very sharp peak. It actually peaks over tonight and tomorrow night. And these things are visible from mid-July all the way through to mid-August, where some of the other meteor showers that we see only peak over the period of a couple of hours. But the important thing here is as the night goes on, as our 4-hour show goes on, it's going to be more and more likely that we catch meteors as we get closer and closer to dawn in these places. And the radiant where these meteors are coming from is going to get higher in the sky. So, it's not the best meteor shower in the world, but it's certainly a great one. And actually, it's quite favorable this year because we don't have a moon to destroy these meteors, the ones that do come out and welcome us tonight.
All right, terrific. So roughly 4 hours is our show tonight. And Paul, you're going to be with me every step of the way, right? You're not going to leave me, are you?
Go on, what's it worth, Jerry? No, I'm going to be here. I'll tell you, I'm going to be glued to the feeds, and I know what we've got coming up. Our experts tonight, I mean, they're great to listen to. There's nothing about meteor showers that viewers are not going to learn from our experts tonight. One of the things I'm looking forward to as well is I bet there's a lot of viewers out there who didn't know that you could listen to meteors. So we're actually going to be listening to them later on. That is really cool. That's a good segment.
All right, our 4-hour tour has begun. Paul, sit back, relax, enjoy. I'll check back with you shortly. And now we're going to give you, our viewers, some time to just sit back and watch the skies for a bit. Coming up during this segment, we'll have Slooh astronomer Bob Berman, one of the special guests that Paul talked about, giving us his insight into meteor showers, what they're all about, why it's important for scientists to be watching them. So please stay tuned on Slooh.
and check these out. It's very special in a number of ways. First of all, Aquariids, what does that mean? It comes from Aquarius. All of the other meteor showers are named for the place where the radiant is located. All shooting stars seem to radiate away from some spot in the sky, and the constellation that that's in gives the meteor shower its name. We use the Latin possessive form. In most cases, it sounds pretty much like the constellation name. That's why we get the Perseids from Perseus, the Geminids, whoa, tremendous shower every December 13th to 14th. That sounds like Gemini. But Aquarius, going from Aquarius, where the accent is on the second syllable, to the Aquariids, accent on the first syllable, that's a little bit of a jump. Anyway, that's where it comes from. This is the Delta Aquariids, named for a faint star that you'd never notice in a million years, popularly known as SCAT, S-K-A-T. Nobody even calls it that, because no one looks in that direction. This is a southerly part of the constellation, and Aquarius, to begin with, is a very rambling, spread out, hard to define constellation. Of all the 13 zodiacal shapes, and I'm including Ophiuchus, because the sun and the moon and the planets spend more time each month or each year passing through Ophiuchus than even Scorpius or Libra or the others. But of all of them, this is the least definable. Not that they all look like what they're supposed to. Capricornus doesn't look like a sea goat, whatever that is. It looks more like a map of New York State, sort of a triangle. And many of the others similarly look obscure, but at least you can pick out the shape of the stars. But Aquarius is not like that. It just spreads all over the place. So this comes from the southern part of that. And if you want to watch tonight, in addition to viewing the meteors here at Slooh, and you go out and look for them, you'll see them zooming up from the south. And that's very different from the Perseids, which come from the north. Perseus is a northern constellation, so a quick way to tell the difference is that if a meteor is traveling very fast and coming from the northeast or north, that's a Perseid. And if it's zooming from the south, generally slower and fainter, that's more likely to be a Delta Aquariid. In fact, it comes all the way from near the star Fomalhaut, one of the loneliest stars in the heavens. Interesting star, spectral class A, very similar to Vega, a much more famous overhead star for North American observers and European observers. Fomalhaut sits more isolated than any other first magnitude star. Same spectral class, same distance even, 25 light years away. But because it's low for people in Canada and the U.S. and Japan, and it's rarely observed, at least not as much. Another way to find the radiant for this meteor shower is to follow the right side of the Great Square of Pegasus. The two stars on the right, just follow them down, down, down to the south. That'll take you to Fomalhaut, and they'll take you to where these meteors seem to zoom away from. They zoom at 26 miles per second. Now, that's medium fast. They're not as slow as the Geminids seen in December, and they're certainly not as fast as the blazing hot Perseids in August, or the Lyrids either, both of which come into our atmosphere at close to 40 miles per second. So these are noticeably slower, and that may be one reason they leave fewer persistent trains. Yep, that's the term for a trail behind a meteor. About 1 in 3 Perseids leave a glowing train, like a Cheshire cat smile, just lingers in the sky for a few seconds after the meteor has burned up and gone to meteor heaven. But in this case, the Eta Aquariids, only about 1 in 10 to 1 in 20 leave behind glowing trains, so they're a little bit less spectacular to see. And on top of that, they're fainter in terms of producing fewer fireballs, really, really bright specimens. So they're more of a challenge, but what the heck? We thought we'd throw them at you this year and observe them tonight, and, our equipment keeps getting better in detecting meteors going across the sky. Every meteor shower really pieces from a comet, I guess, except for the Geminids, whose parent body is a strange object called Phaethon, and it's more of an asteroid than a comet. We're starting to think that sometimes when comets get all used up and their ices have been depleted from repeated passages near the sun, what's left, the little core that's left, can look like an asteroid. So that's the case for that meteor shower. All the others really are bits of comet material, and in some cases famous comets, such as Halley's Comet. The Perseids coming up are the result of the comet Swift-Tuttle, discovered by Civil War astronomers Lewis Swift and Horace Tuttle. In this case, it had not been clear what the parent body is, and even to this day, it's not 100% certain. It seems likeliest that it's part of a comet named 96P, Comet Machholz, named for Don Machholz, who's a very prolific comet discoverer. Some say the most prolific of all naked-eye comets. We have Australian comet discoverer Robert McNaught, who certainly found more comets than anyone else, but most of his comets were not naked-eye objects. Anyway, Don Machholz, and I'm not sure I'm pronouncing his name correctly. Only the owner of a name is the authority on how it's pronounced. I've never met him. Is it Machholz? Machholz? I don't know. I'm not sure. But that's the comet. He discovered it with 5-inch binoculars, giant binoculars, back in 1986, even though the comet's name is from 96 because that's when it was seen and its orbit determined, and that seems to have the same orbit as these objects, and a strange orbit it is. This is one of the weirdest comets. In fact, it's so weird, let's talk about that in a separate segment, because we're seeing fragments of an object that may be among the strangest that ever zoom through the sky. Meantime, we'll keep watching. Again, bit challenging because there are not as many. Typically, you'll see something in the order of 16 of these per hour. Now, compare that to the 60 to 100 meteors per hour that we get with the Perseids, and the 100 per hour that we pretty reliably get with December's Geminid shower. And you can see this is at best maybe only 1/5 the rate of those others, even when they're at their skimpiest. So fewer of them, they tend to be fainter, there's fewer fireballs. Why the heck are we even doing this? Because, first of all, there will be Perseids that we're going to see as well, because both of these showers, this one, the Delta Aquariids and the Perseids, go across the sky for a long period of time, from late July right until mid to late August. True, they have peaks. The peak of tonight's shower here for the Delta Aquariids is tonight. Peak for the Perseids is usually August 12th. But nonetheless, they're seen all these nights. So they're there. They're up there. And, although we're focusing on the Aquarius-based shower, we'll see some Perseids too. So definitely we're not wasting our time. If you love shooting stars, and who doesn't, you've come to the right place. If you live out in the country, have a look for them yourself. Maybe listen to our narration during the show. And if you live in a big city, or if it's cloudy for you tonight, hey, keep watching, and we'll see what we see. And I'll be back in a little bit, talk more about this. For Slooh, I'm Bob Berman. And
We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at slooh.com. Space is limited. Hey there, and welcome back to Slooh, your interface to outer space. I'm Jerry Monteur, your host, and we are back keeping an eye on the Delta Aquariid Meteor Shower. There's a live view from France, for instance. Now, of course, we just heard from Bob Berman, one of our Slooh astronomers and colleagues, telling us all about what meteors are, why they do what they do, and why they're important. But if you missed it, don't worry about it. We'll be streaming that segment with Bob again in a couple of hours, so stay tuned to catch what you might have missed. We're on the air until midnight Eastern time. That last segment also reminded me of what great plans we have for the rest of the summer here at Slooh, with our most exciting event ever, perhaps, coming up in less than a month. We're going to be heading out to Stanley, Idaho for the transcontinental total solar eclipse. We're getting ready for that big road trip, and any astronomer or apprentice Slooh member can join us there for free. It's going to be a terrific week on that campsite. Our friend, Slooh astronomer Paul Cox, getting prepared for his trip out there right now. So when he's back with us here on the show a bit later on, I'm sure he'll be excited to tell us all about what we have to look forward to. And it is a lot, believe you me. Coming up next on this Meteor Shower show, we will have Tricia Ennis, our human spirit correspondent for the evening, telling us about what comets have represented in history. Have they been good things, bad things, in between things? We'll find out on our next segment, so stay with us here on Slooh.
Hello, my name is Trisha Ennis, and I am a cultural correspondent of sorts here. Tonight, we are watching live as bits of space rock burn up in our atmosphere. And as you've already learned, those bits and pieces were actually left behind by the trails of comets. One of the things I enjoy most about studying history is realizing that ancient cultures actually had a much firmer grasp on what was really going on in outer space than I think we like to give them credit. So today, I'm going to talk a little about how these ancient cultures, and even some modern ones, viewed and understood these fascinating bodies whizzing through our solar system. Now, by the time we started keeping records millennia ago, early astronomers had already mapped the stars, named the constellations, even named the planets, and figured out the orbit and phases of the moon. But understanding how things move doesn't mean you entirely understand everything about them. And when there's something you don't understand, it tends to inspire an awful lot of fear and doubt. This was exactly the case with comets. You see, where constellations are constant and more or less unchanging, and planets, even meteor showers like tonight's, are predictable and mappable, comets are much more sporadic and inconsistent, especially without the technology of today. In many ancient cultures, the skies were the domain of the gods, and the events that occurred within that domain was their will. Planets were representations of those gods, but comets, they were harbingers. Most of the time, comets were not bringers of good news. Some thought they looked like the head of a woman or like a blazing sword, and these are not happy images. In fact, many believed they indicated that the gods were displeased and were soon to unleash their wrath on the world. As with most beliefs, especially ancient ones, mythological stories fueled them, and fueled the belief that comets were bad news. They even appear in the most famous and oldest of ancient texts, the Epic of Gilgamesh, where a comet was said to be the first indicator of the deluge, or Great Flood. But myths and legends weren't the only place where comets were said to bring about bad news. Pliny the Elder, the famous Roman philosopher, believed that comets signaled political unrest or death. And, in fact, some Romans believed a comet appeared just before the death of Julius Caesar. Halley's Comet specifically has been blamed for any number of catastrophes. In Switzerland, it was blamed for earthquakes, red rain, and a number of other strange occurrences, including two-headed animals. In England, some blamed Halley's Comet for the Black Death, the terrible plague that killed anywhere from 75 to 200 million people worldwide during the Middle Ages. And Pope Calixtus III even went so far as to have Halley's Comet excommunicated as an instrument of the devil. No word yet on whether they've made up. To this day, and despite all that we know about comets, they remain objects of concern or turmoil. In 1910, when the Earth passed through the tail of Halley's Comet, people all over the world reacted in a variety of ways. From the comet dinners put on by Parisian restaurants to packed churches in the U.S., where parishioners believed that the arrival of the comet signaled the end of time. People even wrote to the Royal Observatory asking whether it was safe to travel by boat during this time, because they feared the comet might cause severe storms. The observatory, of course, told them they had nothing to fear.
We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at slooh.com. Space is limited. And we welcome you back here on Slooh, your interface to outer space. My name's Jerry. We are back with our look at the Delta Aquariid Meteor Shower tonight, and we are ever vigilant and ever hopeful. At its peak, which is happening shortly, at its peak, we are expected to be able to see anywhere from 10 to 20 meteors. We haven't seen much action so far, but that's really not unexpected. It is a moonless night, and that's the good news. And we're getting as closer and closer to peak meteor time, as I mentioned. Well, we just heard from our human spirit correspondent, Tricia Ennis, about what comets and meteors meant through history, why humans feared them before we knew what they really were, of course. Well, so far we've been looking at Slooh's feeds, and we have a number of them around the world: Slovenia, France, Chile, and of course the Canary Islands. And so bear with us and stay with us here on Slooh as we check out the Delta Aquariid Meteor Shower. All right, coming up next, we've got a segment from astronomer and journalist Will Gator, who will be talking about all the ins and outs of how to photograph meteors, what kind of conditions and what kind of equipment you're going to need to snap your very own pictures. So stay tuned here on Slooh.
Hi, my name's Will Gator, and thanks for tuning in to our live coverage here on Slooh.com. Now, if you've been looking at some of our live feeds on the screen, you might have been thinking, oh, I'd really love to try and capture a picture of a meteor tonight as the meteor shower reaches its peak. Well, now's obviously a great time to try because there'll be a lot more meteors than usual in the sky, but there are also lots of other things you need to do to try and do this. And in fact, meteor photography is really quite difficult. You can take hundreds of pictures and really only capture a handful, maybe one or two meteors on camera. So how do you do it? Well, in my experience, the best type of camera for imaging meteors is a digital single lens reflex camera, or a DSLR. And this is because they're particularly sensitive, and you can also use them with very wide angle lenses. And wide angle lenses allow you, of course, to capture a large section of the night sky. Now, there are other types of cameras, certainly some of the modern mirrorless cameras and bridge cameras. They can actually take very sensitive wide field images of the sky. They can use interchangeable lenses as well. But in my experiences, I tend to use a DSLR camera. So what you need to do is basically set up a DSLR on a tripod. That tripod will keep your camera very still, stop any vibrations, and that's crucial because in order to capture a picture of a meteor, you need to make sure that your shutter is open for a fairly long period of time, so perhaps 10 to 30 seconds at a time, and keep the camera firing almost continuously. So in order to do this, one of the things you might find very useful is to have a remote release handset. Basically, you have this set continuously firing in continuous mode. So in modern DSLR cameras like the Canon range of EOS cameras, you actually have a mode that allows for continuous shooting, and so this allows you to take continuous exposures of say 10 to 30 seconds, and hopefully during that time a meteor will flit across your field of view. Now, as I said earlier, the wide angle lenses are the best type of lenses to use really. You don't want to go too wide, because if you have something like a fisheye lens, then even the faint meteors, they won't really show up very well. But maybe a focal length of perhaps somewhere in the region between 14 millimeters and say 20 millimeters is probably ideal for something like a full format, a full frame digital camera. So that's the sort of thing in terms of lenses. And where to point your camera in the sky? Well, this is always a tricky one because, of course, you don't know, we just can't predict when meteors will appear in the sky. But I found that typically, you know, if you want long trails going across your images, around about 45 to 90 degrees away from the radiant, those are good places, because if you point your camera too close to the radiant, you'll only get very short, stubby trails of meteors because of the perspective effect that we see of the meteor trails in that part of the sky. And if you point your camera far away from the radiant, generally you will find that you get much longer trails there. So that's something to consider. Now, what about things like the ISO sensitivity setting on your camera? Well, in this respect, meteor photography, you kind of have to make certain sacrifices over, say, the quality, the fidelity of an image. And I find that actually you really have to push the ISO setting up quite high. In some cases, 1600 to 3200 ISO are the sort of settings. And that might mean that your images are slightly grainy. You might get that chromiance noise, that sort of coloured blotching on camera. But it does mean that if there is a faint meteor that goes across your field of view, you're much more likely to pick it up. So don't worry too much about the quality of your image because, of course, you know what you're trying to do is capture a meteor. So hopefully, if you use all these tips, you might be able to capture a meteor on camera, but it is just luck. I said earlier on that you can take hundreds of frames and only in a few meteors might appear in one or two of those, and that's true. Certainly I've been shooting some of the very, very particularly strong meteor shower peaks, like for example the Geminids in December and even the Perseids in the summer, and I've only caught a handful in a whole night's worth of imaging. Now, of course, if you're lucky enough to own two cameras, then you can put one camera on one side of the sky and another on the other, and that certainly increases your likelihood of seeing something. But what about the sort of processing side of things? Well, one of the cool things you can do is if you carefully take your images into a program such as Photoshop or something like that, you can start to overlay some of the meteor images, and you can find and locate where the meteors are in different parts of the sky, and then you can build a composite to show where the radiant is in the sky. So you can actually put the images together, put the trails into their respective parts of the night sky on a single image, and then you can actually get this view, this sort of star warping view where the meteors all appear to be coming from the radiant, like of course they are in real life. So you can create some really interesting creative images if you take them and process them in a clever way. But as I say, don't worry too much if you don't capture something on film, because it is really down to luck of where those good meteors will appear. But if you get a bright fireball go through your field of view, it can really make your night. So good luck photographing the meteors, and of course if you don't capture any on film, keep an eye on Slooh.com, where we'll have pictures from our live show and our live feeds here. So good luck, and I wish you all the best for your meteor photography tonight. Hi, my name's Will Gator, and thanks for tuning in to our live coverage here on Slooh.com. Now, if you've been looking at some of our live feeds on
We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at slooh.com. Space is limited. And welcome back, everybody. It's the Delta Aquariids Meteor Shower show tonight on Slooh. Well, we just heard from astronomer and journalist Will Gator talking about photographing meteors. But if you missed it, don't worry about it. We'll have a replay of that piece along with all of our other pieces and our terrific guests later on in the show. We're on the air until midnight Eastern time. Stick around to catch all that you might have missed. We've been watching all these feeds for just over an hour now, keeping our eyes on the skies. We are ever vigilant. This isn't one of the more active meteor showers of the year, but we are keeping track of any that we do catch. Scopes all over the world, and I'm not kidding about that. And back with us to talk about those telescopes and what Slooh has to offer is our very own Slooh astronomer, Paul Cox. Paul, welcome back. The
Hey,
good
Jerry.
news is not much in terms of moonlight, and there are spots around the world where the skies are clear, and that's where our feeds are emanating from. So what do we have tonight?
Well, we've got France, we've got Slovenia for the first time, actually. We've got a couple of locations in France. And of course, we have our observatory in the Canary Islands. And we're getting some pretty good feeds. But I haven't seen any yet. But what we really need our viewers to do tonight is really help us out with this, because I'm kind of working and I'm flicking between different feeds and stuff like that. If they spot anything in our live feeds, tweet to @Slooh or use the hashtag Slooh and tell us roughly what you saw, when you saw it, and we can go back and check that ourselves. So more eyes, the better on this one, really, Jerry. But the feeds are coming in great. So we have got clear skies. And what we're doing now is, as I said at the top of the show, the further we go into the show, the more likely these meteors become, because it's in the hours before dawn where you're far more likely to see the meteors. And that's because we've already heard from some of our experts, where the meteors appear to emanate from is called the radiant. And the radiant for the Delta Aquariids is in, guess what, the constellation of Aquarius. It rises. As the night goes on, it is getting higher and higher in the sky. So we start to see a larger area where meteors can appear. So this is a watching game. I mean, we've just heard from Will Gator there. He's been telling us how to photograph meteors. And by the way, that's really easier than a lot of people think, as Will pointed out there. And you can also get some great sky shots of things like this, the Milky Way. Look at this in France, stretching across the sky. Even with your consumer level DSLR camera, you can catch the Milky Way like that. And as Will said, if you're lucky, if you're patient enough, if you're tenacious, then you will also catch meteors, not just on the night of meteor showers, when there are more than usual, but you can also pick up what are called sporadic meteors. These are meteors which aren't associated with a particular shower. So they're not kind of this trail of cometary debris, if you like, that we're hearing from our experts. Oh, I'll tell you a little bit more later on, Jerry, that some of our experts probably haven't told us about this particular meteor shower. So ask me about that anytime later on.
I will. And speaking of night sky photography, that's one of the things that I do. And what I find, Paul, which is fascinating and a lot of fun, is taking shots, exposures 20, 25, 30 seconds long, and then looking at them later and discovering that, hey, I caught a meteor. Isn't that cool?
Yeah, it is. But there's one thing, and we've seen a couple of these examples tonight, actually. There are a couple of things, Jerry, that you can confuse for meteors. Now, I suspect you know these by now. But some of our viewers may not know. When they're looking up in their own night sky, they can get confused. And there are probably three things in the night sky, kind of like a meteor, that we can see. The first one is a meteor. And you'll always see that as a fairly brief spark of light that travels across the sky. They can be quite small, they can be quite short in length, or they can almost stretch uh, the entire sky. I think we've got some video coming up of some of the ones that we spotted over the years over the Canary Islands. But we can also see sometimes when you go outside a point of light which is moving. It's very definitely it's not a it's a light, and it's moving across. Now that might be the International Space Station or another bright satellite. And actually, you see more of those at dusk and dawn, kind of key meteor watching times than at any other time of the night. So the way of spotting that, knowing that it's a satellite, is it kind of moves slow and steady. But the most important thing saying it's a satellite is that it's probably a constant bit of light. It's not blinking, because that's our third object that often gets confused for a meteor, and that's aircraft. But the easiest way of telling an aircraft is they're going to be moving probably faster than a satellite, nowhere near as fast as a meteor, but more than anything else, they are going to blink. Now, if they're very distant, you're not really going to see that blinking light, but in which case they're going to be moving so slow that they're not going to be a meteor. But hopefully we'll see some of these great meteor videos that we've taken over the years. And some of these are called fireballs, Jerry. Now, I've been trying to find out for years, what's the difference between a meteor and a fireball? Do you wonder that, Jerry?
What is the difference?
Absolutely. I reckon it's just about how flash it is, basically, how bright it is. So it's exactly the same kind of object. But instead of some of the meteors that we're going to be seeing tonight, those are caused by tiny particles the size of a grain of sand. But these fireballs are much larger. They're about the size of my thumbnail. But they cause these massive, and it's the speed. It's the speed at which they're hurtling through our upper atmosphere, 90,000 miles an hour, stuff like that. And that's where all the energy comes from. That's how, on these meteors that we're going to see tonight, a grain of sand can light up a huge swathe of the sky as it flashes through and burns up and basically atomizes.
Well, we're looking now at the all-sky camera from our Canary Islands Observatory. The constellation cam, though, I understand, Paul, that's your favorite, isn't it?
It is tonight. It's our best bet, and it's exactly really what Will was talking about there. So here we are. This is a DSLR camera, and it's nothing special. It's put on top of our Canary 3 astrograph telescope, which is a very, very special telescope. But this constellation camera is kind of piggybacked on top of it. And what it's doing tonight is taking 30-second long exposures, just like Will Gator was telling us to do. And you can see here, a normal DSLR camera is good enough to pick up the Milky Way. And that's what we're looking at here. We're looking at the center of the Milky Way. Just before we came on, Jerry, viewers will have seen what looked like a kind of fuzzy patch in the middle of the constellation cam feed. What they were actually looking at was the enormous Andromeda galaxy. So even with a consumer grade DSLR camera this has got the standard kit lens on, would you believe, you can photograph things like the Andromeda galaxy. I mean, that is such a cool thing, and it's a great entry point if you want to start getting into astronomy and maybe astrophotography. So you can use that at home because you can come up with all sorts of starscapes, which is kind of taking a landscape at night with the stars. You've done some beautiful ones. I hope we can get some of those to show a little bit later on. But when it comes to telescopes, a lot of people who try doing a bit of telescope imaging from their own backyard, that is when it can get a bit disappointing. Because frankly, unless you're at a world-class observatory site like the Canary Islands, 8,000 feet up, some of the largest optical telescope is based there for a reason. And we have these huge telescopes, half-meter telescope with these scientific grade CCD cameras. Some of those are well over $20,000 each, something that is well beyond most of us in our own backyards. But that's what you really have to do to get really fabulous results as far as astrophotography is concerned. So if somebody asks me, what can I do, Paul, to get into imaging? I say, join Slooh, because you can use the big telescopes, hundreds and hundreds of thousands of dollars worth of equipment, but you can also very cheaply in your own backyard have great fun photographing the constellations and Andromeda Galaxy and meteors using your standard DSLR camera.
Yeah, it is pretty neat. So we started watching the Delta Aquariids last night. Did we catch any meteors last night, Paul? Do you know?
We did, and I think we probably got some videos of some of those as examples. If we haven't got them now, there's one there, and there it goes. Now, that is actually slowed down dramatically. This is from a very, very special camera. This camera is so sensitive. They can take multiple frames incredibly quickly so that they can freeze frame it. So even though each one of these meteor flashes is only taking less than a second, they've got hundreds of frames of it, so they can study the morphology of it, how it starts to burn up, how it burns up at its peak, and how it then peters out. So here we go. These are those very ones captured by some of the NASA meteor cameras. Pretty cool.
It really is. Wow. Well, speaking of cool stuff, we've been promoting this for quite some time now. We're talking about the eclipse in August. I assume, Paul, listen, I know how hard you work. I know you don't sleep. So tell me about the preparations for the big show in August.
Well, my preparations actually started over a year ago. But if we talk about kind of more recent history, the first leg of my own personal road to totality started last week. I left the UK and got on my flight over to New York. I'm now in Connecticut, where Slooh HQ is based. And so that's kind of the start. That's actually one of the longest legs of my entire eclipse journey this year. But in a week's time, Mike Palucci, the founder of Slooh, and I are getting in the Slooh Mobile Observatory, and we are traveling from Connecticut. We're starting at the Science Center in Hartford, the Connecticut Science Center. I think that's on Monday the 7th. And we are heading across country, kind of mirroring the line of totality. So this is the line that's crossing the entire United States, is only about 60 to 70 miles wide. And if you're outside of that, you're only going to see a partial eclipse. If you're in that, you're going to see a total solar eclipse. But we're going to be traveling along there to our fabulous Slooh community event and festival, our Eclipse Festival in Idaho, which is very close to, we're very close to the town of Stanley. So that's going to be a pretty cool event.
Well, you know, there's a saying, membership has its privileges, and so I want to talk about. First of all, I'd like to welcome people watching this broadcast on both Facebook and YouTube, and encourage them to come to slooh.com, and further encourage them to become members of the Slooh community, because in this case, Paul, membership really does have its privileges and advantages, especially when it comes to what we're doing in Idaho.
It certainly does. I mean, forget about the fabulous telescopes that you can control every night from the comfort of your own armchair. Slooh apprentice and astronomer members can join us for our Eclipse Festival in Stanley, in Idaho. And the best thing is, it's free of charge for members. We've got a huge campsite. We've got bands, music lined up. We're going to have nighttime observing. We're going to have our Slooh Coronado telescope that's been provided to us by Meade Instruments. And we're going to be using that actually all along our journey. So we're stopping off. We've got loads of media interviews and stuff like that along our journey. And we're going to be stopping, pulling up the Slooh Mobile Observatory, getting the solar telescope out. And this particular telescope, highly specialized. It's a bit like our Slooh solar telescope in the Canary Islands. Wow. The members love that one. But anyway, anybody's going to be able to have a look at this. They can find this on the street. They can have a look through this. But we're also taking that to the festival. We got some nighttime telescopes as well that we're using. Other members are bringing DSLR cameras, their telescopes. We're going to have night viewing sessions, solar observing sessions during the day. It's running for the whole weekend. So it's going, I think you said Friday to Monday, isn't it? Encompassing the whole eclipse weekend. And we're certainly encouraging any members to arrive early, because word is already out that there is going to be gridlock from anywhere in the United States towards that path of totality. So all people have got to do is sign up, become an apprentice or astronomer member of Slooh. Then they can register their place at the campsite and they can join us. And it is going to be an absolute ball. I mean, first of all, I mean, the Slooh community is a great online community anyway. Everybody always shares their expertise. We all remember when we first started off in astronomy, you know, how daunting it can be. And we remember that when new members come in, you know, so there's always a helping hand, always somebody to take you to the next stage of your hobby. So if that's what it's like online, it's going to be even better being able to do this face to face. We've got a long-time Slooh member and comet hunter, Christina Feliciano. She's going to do a pancake morning for everybody who's there. How cool is that? You know, and we've got loads of stuff like that happening. So what the community is doing is actually what they do in the normal Slooh community. Everybody's kind of contributing to make that festival one of the most memorable eclipses in history.
There you have it. Become a Slooh member. Party with Paul and Palucci in Idaho. All right, Paul, we've got about another, 2.5 hours to go in our coverage of the Delta Aquariid Meteor Shower. Meantime, up next, we've got Slooh astronomer Bob Berman, who will talk us through the whys and wherefores of the Delta Aquariids, how they got their name, and just the kind of meteor shower this is compared to others that happen throughout the year. So stay with us.
First of all, Aquariids, what does that mean? It comes from Aquarius. All of the other meteor showers are named for the place where the radiant is located. All shooting stars seem to radiate away from some spot in the sky, and the constellation that that's in gives the meteor shower its name. We use the Latin possessive form. In most cases, it sounds pretty much like the constellation name. That's why we get the Perseids from Perseus, the Geminids, whoa, tremendous shower every December 13th to 14th. That sounds like Gemini. But Aquarius, going from Aquarius, where the accent is on the second syllable, to the Aquariids, accent on the first syllable, that's a little bit of a jump. Anyway, that's where it comes from. This is the Delta Aquariids, named for a faint star that you'd never notice in a million years, popularly known as SCAT, S-K-A-T. Nobody even calls it that, because no one looks in that direction. This is a southerly part of the constellation, and Aquarius, to begin with, is a very rambling, spread out, hard to define constellation. Of all the 13 zodiacal shapes, and I'm including Ophiuchus, because the sun and the moon and the planets spend more time each month or each year passing through Ophiuchus than even Scorpius or Libra or the others. But of all of them, this is the least definable. Not that they all look like what they're supposed to. Capricornus doesn't look like a sea goat, whatever that is. It looks more like a map of New York State, sort of a triangle. And many of the others similarly look obscure, but at least you can pick out the shape of the stars. But Aquarius is not like that. It just spreads all over the place. So this comes from the southern part of that. And if you want to watch tonight, in addition to viewing the meteors here at Slooh, and you go out and look for them, you'll see them zooming up from the south. And that's very different from the Perseids, which come from the north. Perseus is a northern constellation, so a quick way to tell the difference is that if a meteor is traveling very fast and coming from the northeast or north, that's a Perseid. And if it's zooming from the south, generally slower and fainter, that's more likely to be a Delta Aquariid. In fact, it comes all the way from near the star Fomalhaut, one of the loneliest stars in the heavens. Interesting star, spectral class A, very similar to Vega, a much more famous overhead star for North American observers and European observers. Fomalhaut sits more isolated than any other first magnitude star. Same spectral class, same distance even, 25 light years away. But because it's low for people in Canada and the U.S. and Japan, and it's rarely observed, at least not as much. Another way to find the radiant for this meteor shower is to follow the right side of the Great Square of Pegasus. The two stars on the right, just follow them down, down, down to the south. That'll take you to Fomalhaut, and they'll take you to where these meteors seem to zoom away from. They zoom at 26 miles per second. Now, that's medium fast. They're not as slow as the Geminids seen in December, and they're certainly not as fast as the blazing hot Perseids in August, or the Lyrids either, both of which come into our atmosphere at close to 40 miles per second. So these are noticeably slower, and that may be one reason they leave fewer persistent trains. Yep, that's the term for a trail behind a meteor. About 1 in 3 Perseids leave a glowing train, like a Cheshire cat smile, just lingers in the sky for a few seconds after the meteor has burned up and gone to meteor heaven. But in this case, the Eta Aquariids, only about 1 in 10 to 1 in 20 leave behind glowing trains, so they're a little bit less spectacular to see. And on top of that, they're fainter in terms of producing fewer fireballs, really, really bright specimens. So they're more of a challenge, but what the heck? We thought we'd throw them at you this year and observe them tonight, and, our equipment keeps getting better in detecting meteors going across the sky. Every meteor shower really pieces from a comet, I guess, except for the Geminids, whose parent body is a strange object called Phaethon, and it's more of an asteroid than a comet. We're starting to think that sometimes when comets get all used up and their ices have been depleted from repeated passages near the sun, what's left, the little core that's left, can look like an asteroid. So that's the case for that meteor shower. All the others really are bits of comet material, and in some cases famous comets, such as Halley's Comet. The Perseids coming up are the result of the comet Swift-Tuttle, discovered by Civil War astronomers Lewis Swift and Horace Tuttle. In this case, it had not been clear what the parent body is, and even to this day, it's not 100% certain. It seems likeliest that it's part of a comet named 96P, Comet Machholz, named for Don Machholz, who's a very prolific comet discoverer. Some say the most prolific of all naked-eye comets. We have Australian comet discoverer Robert McNaught, who certainly found more comets than anyone else, but most of his comets were not naked-eye objects. Anyway, Don Machholz, and I'm not sure I'm pronouncing his name correctly. Only the owner of a name is the authority on how it's pronounced. I've never met him. Is it Machholz? Machholz? I don't know. I'm not sure. But that's the comet. He discovered it with 5-inch binoculars, giant binoculars, back in 1986, even though the comet's name is from 96, because that's when it was seen and its orbit determined, and that seems to have the same orbit as these objects, and a strange orbit it is. This is one of the weirdest comets. In fact, it's so weird. Let's talk about that in a separate segment, because we're seeing fragments of an object that may be among the strangest that ever zoom through the sky. Meantime, we'll keep watching. Again, bit challenging because there are not as many. Typically, you'll see something in the order of 16 of these per hour. Now, compare that to the 60 to 100 meteors per hour that we get with the Perseids, and the 100 per hour that we pretty reliably get with December's Geminid shower. And you can see this is at best maybe only 1/5 the rate of those others, even when they're at their skimpiest. So fewer of them, they tend to be fainter, there's fewer fireballs. Why the heck are we even doing this? Because, first of all, there will be Perseids that we're going to see as well, because both of these showers, this one, the Delta Aquariids and the Perseids, go across the sky for a long period of time, from late July right until mid to late August. True, they have peaks. The peak of tonight's shower here for the Delta Aquariids is tonight. Peak for the Perseids is usually August 12th. But nonetheless, they're seen all these nights. So they're there. They're up there. And, although we're focusing on the Aquarius-based shower, we'll see some Perseids too. So definitely we're not wasting our time. If you love shooting stars, and who doesn't, you've come to the right place. If you live out in the country, have a look for them yourself. Maybe listen to our narration during the show. And if you live in a big city, or if it's cloudy for you tonight, hey, keep watching, and we'll see what we see. And I'll be back in a little bit, talk more about this. For Slooh, I'm Bob Berman. And check these out. It's very special in a number of ways. First of all, Aquariid.
We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at slooh.com. Space is limited. Hey there, and welcome once again. Welcome back to Slooh, and thanks so much for joining us. I'm Jerry Monteur, and we are keeping a close eye on the Delta Aquariid Meteor Shower tonight. And I want to bring Paul Cox back in right now because, Paul, we have some very good news, my friend. We have a meteor, and it's courtesy of our all-sky cam in Brazil. And as you mentioned earlier, this meteor shower is probably best seen from the southern hemisphere, and there's our first meteor of the night.
Exactly, and it's quite difficult to tell from there, but it is very distinct. We looked at there's a little animation about this as well, and it is very clearly a Delta Aquariid meteor. And we were saying that it is better seen from the south, and it's kind of, you can see it from the northern hemisphere, but you just see more and more meteors the further south you go. And I don't know if we've checked in on our Chile Observatory all-sky camera recently, but Slooh members can use the telescopes in the southern hemisphere as well, so they can see the whole sky. And oh, look, it's still pesky clouds. Well, that cloud is actually clearing a little bit. We got the moon is close to setting, so once that's out of the way, if those pesky clouds move away, first of all, the domes will open and the Chile telescopes will be at the command of Slooh members, but we should also see actually stand a far better chance of seeing some meteors in our Chile all-sky camera than really our Canary all-sky camera. But the counter to that is the Canary Islands is now kind of getting closer and closer to dawn, which is when most meteor showers, including the Delta Aquariids, tend to become a little bit more prolific.
Well, we just had a very informative segment from Bob Berman about where the name of this particular meteor shower comes from and the specifics of it as well. But Paul, there's a very good, strong Slooh connection to this one, isn't there?
There is indeed. Bob was saying that the Delta Aquarius, most meteor showers, we know very clearly what their parent body is. And as Bob explained there, that they're caused by the debris left by comets as they orbit the sun. But this one, we're not entirely sure. We think it might have been caused by the trail left by some sun-grazing comets. And sun-grazing comets often don't survive their close encounter with the sun. But more recent thinking is that it's comet Machholz, as Bob said, which may be the parent body that left the stream of debris that the Earth is passing through tonight. And the connection to Slooh there is that Don Machholz, the discoverer of that and some other comets, is a Slooh member and has been for donkey's years now. And a lot of his comets that he's discovered, including this one, I think it has a very short periodic period, which means it goes around the sun. I think it's only 5 or 6 years. It's very quick. Anyway, every time it comes round, Don uses the telescopes that we can see actually just in the left of this image. We can see the half-meter telescope, which is an enormous telescope that the Slooh members use. And Don uses that to recapture his comets. And this is called recovery. So comets are first discovered. Somebody then confirms them, takes the first confirmation images. That's when it's named. But then as a comet, as a periodic comet, kind of moves further away from the sun, the activity drops down, it gets further away from Earth, it drops in brightness, which means that often we can't see them for a lot of their orbit. So what happens when they start to come back? We kind of know with relative certainty where a comet is going to be if it's been observed over a number of years. But there's still some uncertainty, and there's also great uncertainty with all comets when it's going to start really putting on a show and some activity. So one of the things that comet hunters do, and there's a whole team of Slooh members that do this, is they try and get what's called a comet recovery. And this is what Don does. So this is the first person to spot the comet when it comes back towards the Earth and the Sun. And it's great fun. And Don always does this. And I think he achieved that 2 years ago with one of his comets. He used the half-meter telescope and bang, there it was. It was like Don wasn't happy enough discovering the comet in the first place, so he discovered it all over again as well.
I want to be that guy. I want to be that guy. Again, membership has its privileges. All right, Paul, thanks a million. We'll talk with you shortly. Bob Berman, if you missed his segment, don't worry about it. We'll be replaying it later on in this broadcast, so stick around. You can see any segments that you've missed. We've had some great ones tonight. You definitely don't want to miss them. All right, coming up next, we've got some poetry provided by Tricia Ennis, our human spirit correspondent. This poetry is some work from poets who were inspired by comets and meteors and other shooting stars. Stay tuned.
Hello, and thanks for joining us here on Slooh. My name is Tricia Ennis, and tonight I want to talk a bit about shooting stars. I don't know if this extends to all of us, but I can certainly say that when I was growing up, my parents would always tell me that if I saw a shooting star, I should make a wish. Like birthday candles, wishbones, or a stray eyelash, shooting stars are sporadic events seen as signs that now is the time to ask the universe for something we desire. The poet Dorothy Parker even wrote a poem about wishing on a star titled Starlight, Starbright. Star that gives a gracious dole, what am I to choose? Oh, will it be a shriven soul or little buckled shoes? Shall I wish a wedding ring, bright and thin and round, or plead you send me covering a newly spaded mound? Gentle beam shall I implore, gold or sailing ships, or beg I hate forevermore a pair of lying lips? Swing you low or high away, burn you hot or dim, my only wish I dare not say, lest you should grant me him. Looking to the universe, a vast open expanse we know little about, where gods reside and angels or spirits travel, and asking it, in whatever form we believe it takes, to intervene in our lives, is something I think a lot of us can relate to. Asking the universe for something is, in a way, an acceptance of the lack of control we have in our lives, a way of giving ourselves over to something greater than we are. I suppose you could argue that artists do something similar, attempting to express a feeling greater than simple explanation or conversation through images or stories or poetry. Artists and musicians and poets and writers have spent centuries attempting to express their own connection to the universe through their work. It's difficult to say where exactly the idea of wishing on a star began, but many believe it was from the ancient Greek astronomer Ptolemy, who was also the first person to catalog the constellations. Ptolemy claimed that when the gods were curious or bored, they would occasionally peer out of the sky through the spheres where stars could slip through and fall to Earth. It was believed that the gods would be exceptionally open to granting wishes at this time. Special significance has been placed on shooting stars because of their rarity and because of their splendor. I would defy anyone to watch a shooting star and feel nothing. That feeling of awestruck wonder and momentary excitement is what makes events like meteor showers so powerful for some. It's a serene connection to the universe and an anticipation paid off by a fleeting glimpse of a dying rock. We spend our lives looking for moments that will make the other, more mundane experiences worth our time, and shooting stars, for many, represent those brief periods of connection and visceral experience, a sentiment at the heart of the Pulitzer Prize-winning poet Arthur C.'s piece, Shooting Star. In a concussion, the mind severs the pain. You don't remember flying off a motorcycle and landing face first in a cholla. But a woman stabbed in her apartment by a prowler searching for money and drugs will never forget her startled shriek die in her throat, blood soaking into the floor. The quotidian violence of the world is like a full moon rising over the Ortiz Mountains. Its pull is everywhere. But let me live a life of violent surprise and startled joy. I want to thrust a purple iris into your hand to give you a sudden embrace. I want to live as Wang Shishi lived, writing characters in gold ink on black silk, not to frame on a wall, but to live the splendor now. Deprived of sleep, she hallucinated and, believing she had sold the genetic research on carp, signed a confession. Picking psilocybin mushrooms in the mountains of Veracruz, I hear tin cowbells in the slow rain, see men wasted on pulque, sitting under palm trees. Is it so hard to see things as they truly are? A route marked in red ink on a map, the shadows of apricot leaves thrown in the wind and sun on a wall. It is easy to imagine a desert full of agaves and golden barrel cactus, red earth, a red sun. But to truly live, one must see things as they are, as they might become. A wrench is not a fingerprint on a stolen car, nor baling wire the undertow of the ocean. I may hallucinate, but see the men in drenched clothes as men who saw and refused to see. Think of being a judge or architect or trombonist, and do not worry whether thinking so makes it so. I overhear two men talking in another room. I cannot transcribe the conversation word for word, but know if they are vexed or depressed, joyful or nostalgic. An elm leaf floats on a pond. Look, a child wants to be a cardiologist, then a cartographer, but wanting so does not make it so. It is not a question of copying out the Heart Sutra in your own blood on an alabaster wall. It is not a question of grief or joy, but as a fetus grows and grows, as the autumn moon ripens the grapes, greed and cruelty and hunger for power ripen us, enable us to grieve, act, laugh, shriek, see it all as the water on which the elm leaf floats. Write out the memories of your life in red gold disappearing ink so that it all dies, no lives. Each word you speak dies, no lives. Is it all at once in the mind? I once stepped on a sea urchin, used a needle to dig out the purple spines, blood soaked my hands. But one spine was left, and I carried it 1,000 miles. I saw then the olive leaves die on the branch, saw dogs tear flesh off a sheep's corpse. To live at all is to grieve, but once, to have it all at once is to see a shooting star, shooting star, shooting star. Hello, and thanks for joining us here on Slooh. My name is Trisha Ennis, and tonight I want to talk a bit about shooting stars. I don't know if this extends to all of us, but I can
We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at Slooh.com. Space is limited. And welcome back as we head into hour number 3 of our coverage of the Delta Aquariid Meteor Shower tonight. By the way, Slooh is getting loads of new members tonight while we watch our coverage of this meteor shower. So we just want to give a warm welcome to a couple of our newest members, Marlon Isguera and Alan Kloos. I sure hope I'm pronouncing that right, but you know who you are. And welcome to Slooh, fellas. And we hope you're enjoying the show and enjoying your new membership. And if you join us tonight, you too might get a shout out. So head on over to Slooh.com, sign up, and see if we give you a personalized how do you do during our coverage tonight. Well, we just heard from Tricia Ennis, and tonight we've had segments by Slooh astronomer Bob Berman, who has told us all about the science behind meteor showers and why they're so interesting to the scientific community. We also heard from astronomer and journalist Will Gator about how to photograph meteors. But did you know you can also hear them? That's right, you can hear meteors. And coming up next, we'll have Will Gator back on again, this time to talk about how to listen to meteors with radio detection. And we'll have a chance to listen to those meteors ourselves. So even if we can't see them, we might be able to hear them. So stay with us.
Hi, I'm Will Gator, and thanks for tuning in to our live coverage here on Slooh.com. Now, one of the things we're doing tonight is using a special radio meteor detection feed to listen out for the sounds of meteors coming through our atmosphere. So, how does this work? How can we hear meteors, which are a visual phenomenon, really? Well, let's think first about what causes a meteor. A meteor is caused by a tiny grain of space dust hitting the Earth's atmosphere, high up in the Earth's atmosphere. And these grains of space dust hit the atmosphere at tremendous speeds, and they compress the air ahead of them. And that compression causes a gas to heat up to really quite extraordinary temperatures. Now, it's a little bit like when you're pumping up the tyre on your bike. As you pump the pump really hard, you'll notice that the air, well, the actual pump itself, starts to get really quite warm. The pump will feel warm, and that's because the air, the gas inside the pump, is being compressed. Well, it's similar to what's happening in a meteor, except you've got to remember that meteors are hitting the Earth, the grains of space dust are hitting the Earth's atmosphere at tens of kilometres a second, so the heating is really, really intense. And that heating begins to heat up the air around the space dust, around the little grain, and also the grain itself. And that's what we see when we see that glowing flash of light, this very, very energetic release of energy as the air is heated up. And it creates something that we call an ionized trail. And it's that's crucial to our radio meteor detection feed, because the way our radio meteor detection feed works is we have one antenna which is placed in one part of the country, and then that is tuned in to a transmitter that is beyond that antenna's horizon, so it can't normally hear that transmitter, except if it has some means for the radio waves from the transmitter to be reflected from high up in the atmosphere back towards it. And that's what the ionized trails of meteors do. They act like mirrors to radio waves so that we can listen very briefly, momentarily, to the transmissions of a transmitter that's far over our horizon. And what we hear are these beautiful sort of whistles and bings. So you will hear these little sounds occasionally, and those are the sounds of meteors coming through our atmosphere. So this is that momentary transmission of a transmitter that's far over the horizon, and that's what's causing these rather otherworldly whistling sounds that we occasionally hear. Now, you will hear the background sort of static, but we also have the means to visualize these radio detections, and so you'll see these trails on the screen, and those are basically the radio detection trails. So that kind of visualizes the sounds that we're looking out for, and particularly strong meteors. If we have a sort of big meteor come through the atmosphere, these trails, these sort of whines and whistles, they can last quite a long time, and they can be quite loud, so do listen out for them, because it's quite extraordinary when you hear a big meteor come through. Now, the only problem with radio meteor detection is we can't tell what direction the meteor was coming from. So listen out for those radio meteors. It's quite soothing, I think, to listen out for them in the background and hear those little pings and those little whistles. It's another way that we can actually listen and enjoy this incredible phenomena. And it works, of course, and this is the brilliant thing, it works even if we have cloudy skies. So good luck looking out for them, and let's see if we can hear some of those beautiful pings and whistles as those tiny little grains of space dust vaporize high up in our atmosphere.
We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at slooh.com. Space is limited. And hello and welcome back to Slooh, your interface to outer space, if you will. I'm Jerry Monteur. We are back with our coverage of the Delta Aquariid Meteor Shower. I want to welcome our friend, Slooh astronomer Paul Cox, back to the program. Paul, we are watching for and listening, as we just heard and saw. We are listening for meteors too. Give me your impressions of the idea, the concept of listening for meteors.
Well, one of the brilliant things with it is that you don't have to wait for darkness. You can actually do that radio meteor detection during daylight because the radio waves still travel around during the day. But I think Will said in this segment, didn't he? I kind of like sitting back and listening to this. I find it really relaxing.
Yeah, he did say that.
I'm sorry, Will. I can't agree with you, mate. It's white noise. They use it in torture chambers, for goodness sake. It sets my teeth on edge when we listen to it. And the studio know that. So the studio left it on slightly longer than they normally would have done this evening. Thank you, studio.
They don't like you very much, but you already knew that.
Exactly,
so we've been watching these images all night from all over the world, Paul, but Slooh has some very special observatory feeds that we've been looking at too. So tell us about those.
Well, we've got all of our Canary Islands special cameras on the night sky to try and catch some of these meteors. This is our all-sky camera, and this is looking really quite murky now. It doesn't usually look like this. That yellow haze that we're seeing all over the place is this, in fact, that's getting pretty close to us having to close the big telescopes. That's dust. Some dust-laden air coming in from the Sahara Desert. And actually, when you're over there, when it's like that, you can actually smell it. It kind of gives an electric feel to the air. And actually, it does generate quite a lot of static as well. Even at points in Tenerife and the Canary Islands, they have to close the airports because of this dust. It's a dust storm, and they call it La Calima. Most countries in the Mediterranean have similar phenomena where they get this dust just blowing up from Africa onto them. But the Canary Islands is a volcanic chain of islands. That's why it's so good as an astronomical site. This is a volcano. We're looking at the Slooh Observatory, where the Slooh members control the telescopes. That's on an 8,000-foot high volcano in the middle of the Atlantic Ocean. Not the middle of the Atlantic Ocean, but the Atlantic Ocean, which kind of normally gives it this really smooth air layer, which is what you want for astronomical observing. You don't want this. You don't want loads of stuff in the atmosphere. And that is just all stuff. It's little grains of sand and dust in the air, which is kind of making the images a lot noisier than they normally would be. But anyway, that is our constellation cam. That's actually the camera that Slooh members use to monitor sky conditions, so they can see their image. Woo, that's a little bit noisier than normal. They can look at that and immediately know why. This is our constellation cam. This is one of my favorites. It's mounted on top of our new Canary 3 Deep Sky telescope. And this is an extraordinary instrument. You can't use it visually. Most telescopes you can put an eyepiece on the back of or a camera, but this particular type of telescope, called an astrograph, you can only use it with a camera. And in fact, the camera attaches to the front of the telescope. And ever since last week, I actually sent the Slooh team some quotes from some of our members in the Slooh astronomer boards, where members kind of hang out and discuss stuff. And I've never seen a new telescope that we've launched become so popular so quickly. And that's not the telescope that we're watching now. This is our constellation cam, and this is perched on top of this other camera. But I've just been looking at some of the live image streams coming in from that. And we've got members looking at the Lagoon Nebula, which looks absolutely beautiful. The Trifid Nebula, the Eagle Nebula looks absolutely superb, and possibly one of the best objects we've seen in it yet, the Andromeda Galaxy. The Andromeda Galaxy is vast, not only in reality, but its apparent size in the night sky as well. It's huge. It's bigger than the full moon, but obviously it's really faint. But this new telescope has this really wide field of view, and it fits the entirety of the Andromeda Galaxy, plus the two little companion dwarf galaxies next to the Andromeda Galaxy, all within one field of view. And one of our members published in the Slooh Astronomer boards his image of the Andromeda Galaxy, and it is glorious. So it's really, really popular. That telescope and the other one that we obviously can't use tonight, the Canary Islands Solar Telescope. This is our special solar telescope that looks at the sun in the hydrogen alpha wavelength. Don't worry too much about that. But what it means is we can see all of this beautiful surface detail. We can see prominences coming off the edge of the sun. We can watch filaments. We can watch sunspots. And all of this activity, Jerry, is coming over a live video stream all day long from the Canary Islands Observatory. And you can watch all of these features change kind of minute to minute and hour to hour. We even saw 10 days ago this enormous active area, which actually on the 16th of July, I think, caused aurora all around the world, both north and south, lit up the night sky. But more than that, on Saturday or Sunday, I think it was, this active region, the sun spins around, of course, it had gone out of our view, but it was on the back of the sun. And the space solar telescopes captured what can only be described as a gargantuan, it was colossal, a coronal mass ejection. This is the sun basically exploding this high energy into the solar system and directly towards Mars. Now, if that active region had actually done that when we were watching it, in other words, when it was facing Earth, chances are we wouldn't be talking tonight, because we wouldn't have very many satellites left in the sky. We wouldn't have very many electrical systems left, to power ourselves. This thing was enormous, and it only goes to show kind of the threat from space. But that's something that Slooh members can enjoy every day. But the other ones that we're looking at tonight, we've got our special low light meteor cam. Now this one this is a live video feed. It doesn't have very many frames per second, and this looks a bit grainy. And that's because during our last segment, I've tuned it up a bit, which has kind of increased the brightness that it's showing, which is why it's showing so much of a bright sky. But what it's done is it's increased its sensitivity. And I'm pretty hopeful that we should actually see a couple of meteors within the next, what have we got, hour or so in this particular feed. So the studio can maybe focus on that one a little bit as we move into the last kind of segment of the show.
So Paul, this meteor cam we're looking at right now, pretty colorful stuff too.
Yeah, it is. It is a color camera, and most astronomers know that as soon as you go to a color camera versus a monochrome camera, grayscale camera, you lose sensitivity, but you do get, a lovely color live image stream. But most of our telescopes that the Slooh members use, they're equipped with grayscale cameras, and they're incredibly sensitive, but they still produce a color image because they take images through clear red, green, and blue filters, and then Slooh's patented technology miraculously processes all of that in real time to provide a live color image stream. But actually, Jerry, the camera I was just talking about, the Canary 3 Deep Sky telescope, that actually has what's called a single shot color camera on it, and that produces color right from the outset. And the image on that, when you watch it live on the telescope page, it just builds and builds and builds. So that's what you see the Andromeda Galaxy, kind of starts off a little bit pale, but then it builds in color until all of these rich colors kind of start popping out. And that's when members are kind of pressing the snap image button for them to capture their own images from those live feeds.
Yeah, it's pretty neat stuff. All right, now back to the meteor shower that we're keeping an eye on. We've seen one for sure. We know we've seen one, Paul. So it's a pretty low activity shower, at least so far, 15 to 20 at its peak per hour. Yeah. But what is the difference between meteor showers? Why is one low activity and another a higher, like say the person?
Well, we've heard from Bob that the cause of meteor showers is the debris trail left in space as a comet whizzes through the solar system. So all it is, it generates more or less meteors depending on how much material it's left behind in that trail. So tonight, we think this is possibly caused by a couple of sun-grazing comets that no longer exist, or maybe this comet that was discovered by Slooh member Don Matcholz. And it hasn't left as much of a debris trail, or that debris trail has kind of dissipated in space. So it's become thinner. So these little particles, these tiny, tiny particles, probably the size of a grain of sand that generate these beautiful meteors, they're just more spread out, basically. Whereas something like the Perseid meteor shower, those streams are really quite condensed. There's a lot of material in a very small kind of pipe, almost a virtual pipe. And that's also, Jerry, why things like the Perseid meteor shower, the peak occurs in a very short period of time because the Earth is passing through a very kind of narrow stream of material. So there's a lot of them crammed into one period of time, but the Earth passes through it quite quickly. Whereas tonight, this stream is really quite diffuse over a large area, large enough, in fact, so that we start seeing Delta Aquariid meteors in the middle of July, and they go on until the middle of August, and they peak around these 2 days. And over the 2 days, it's roughly the same number of meteors. With the Perseid meteors, you're seeing 50 an hour, but only over a very short period of time, only over a couple of hours of peak. So that's the difference. It's just how dirty, I guess, these comets leave the solar system.
And Paul, in the past, we've gotten some terrific images of meteors, haven't we?
We have. I mean, these cameras are running all the time, especially our all-sky camera, and that automatically generates a time lapse in the morning made up of all of those images that we've collected. So it's very easy for members to kind of look at the whole of last night. And that's pretty cool anyway, because you start seeing the whole time lapse. So you see the sky, the stars, the Milky Way, the planets all kind of moving over, and bang, there, you saw it. That is such a classic. I think that one is a Perseid meteor. That is so bright, so unmistakable. I mean, that's a fireball. That's so big. And I was actually at the Observatory, particular meteor shower, and members of the public can drive up quite close. They can't get into the observatory site, but they can drive up quite close. And I was sitting there working in the dome, my head down, unfortunately, so I wasn't able to be watching the meteors. But I knew when they had happened. I mean, usually that place is so silent. I'm on my own. I don't see anybody for such long periods. It's silent other than the music I play out there. But every time a big fireball went over, there were oohs and ahs, this kind of echo across the whole of the top of the volcano, with all of these, sky watchers, these meteor watchers, watching these brilliant, brilliant meteors.
Oh, there we go.
Another one just there. Yeah.
Yeah, this is wonderful stuff. Absolutely fantastic. Again, we're keeping tabs on the Delta Aquariid Meteor Shower, and these are images captured from Slooh observatories through the years.
And there's another one. So, I mean, these are all absolutely classic. And actually, this particular instrument, I made a post to our community content, which is where anybody can post material about their particular perspective on space. And I posted a little there was a golden moment for this particular little camera that's been sitting up there on the top of this mountain for, I think I installed it about 5 or 6 years ago. And it clicked over to have taken its 2.5 millionth image. It just sits there 24 hours a day. We've had lightning signals. We've captured lightning in this thing. We've captured ice storms. It's been buried under the snow, but it has never, ever stopped taking an image every single 30 seconds for that entire duration. I just think it's a miraculous little piece of equipment. I really do.
Yeah, it's fantastic stuff. So, Paul, I want to talk once again about perhaps the most important and most highly Slooh has been part of, and that, of course, is the up on August 21st. And you're a key part of that, Paul. So tell us what's going into the preparations for this program.
Well, virtually the entire Slooh team are working on our solar eclipse coverage, transcontinental eclipse. This is probably going to be one of the most widely viewed eclipses ever, solar eclipses for certain, mainly because virtually the entirety of its path, the path of totality, covers a landmass. You know, usually on most eclipses, we've been to the Faroe Islands where it only touched ground. You know, you could only see this thing from the Faroe Islands and one tiny little island off the coast of Norway. Otherwise, you had to be on a boat seeing this thing. I've been to the middle of Kenya, where we had to go into this tiny, tiny part of Africa just to get onto this tiny stretch of land where we could witness totality. But this one, stretching coast to coast. And we are starting the Slooh Eclipse road trip. Mike Palucci, the founder of Slooh, and myself on these, I think it's the 7th of the month. We're starting a 2-week journey from here in Connecticut. We're starting at the Connecticut Science Center in Hartford, and we are legging across the country with a Slooh mobile observatory with solar telescopes, night telescopes, that people in the street, we're going to accost them and say, you have to look at the sun through this telescope. You'll never look back. You'll never look at anything in the same way. And we're going to be doing that for the entire journey. We've got loads of media stops as well until we finally reach our destination at the weekend of our festival, our Eclipse Festival in Stanley, Idaho. And wow, that is going to be the core of our event. I know you're going to be hosting our full coverage from the very beginning of the eclipse right to the very end. And I think I'm going to be joining you for several times, reporting from our campsite.
Well, I certainly hope so, Paul. And since you're a key component of this thing, if not the most important part of
No.
the preparation for this program, and what's interesting to me is the fact that because of social media, and Slooh's a big part of that, because of social media, there's probably not a corner of the planet that won't be able to watch it.
Exactly. I mean, our coverage is going to be absolutely everywhere. And one of the things that we're doing, because so many people, certainly in the USA, are going to be able to watch a partial eclipse or be in the path of totality and watch the total eclipse with their own eyes. And if you get the opportunity, if you're in the States, please don't watch a partial eclipse. Get down to that path of totality. You can't by any means measure a partial eclipse to a total solar eclipse. So you have to be in that path to really understand what people are talking about, how amazing these events are. But what we're doing, because so many people can watch it with their own eyes, yes, we're always going to have our normal live feeds, our spectacular live feeds. We're going to be using our new Coronado solar telescope from Meade Instruments for our eclipse feed in Idaho. But we're really saying to people who are watching it with their own eyes, preferably with some Slooh eclipse glasses on, let us be your soundtrack, your eclipse watching soundtrack, because we've got the usual lineup of spectacular expert guests, and also because Slooh members are going to be joining us for our campsite festival in Idaho. I'm going to be interviewing loads of those guys as well on the site. And that's what we're really looking forward to most of all. You know, this is the first time so many of us as Slooh members have actually met face to face. You know, we've been collaborating on, you know, watching asteroids and comets for all of these years. And we kind of know each other in the virtual world and in the virtual Slooh community, but we've never met face to face. So that's actually what I'm really looking forward to. And I think they are going to be key. They're the key ingredient to make this particular eclipse the best one that I've ever been to, certainly.
And all the more reason to become a Slooh member, because if you are a member, then you come to Idaho and you camp with us for free and you party with us for free. And it's going to be a great time. Paul, thanks once again for joining us. We'll check back with you shortly, my friend.
Bye for now.
And coming up next, another segment from our human spirit contributor, Trisha Ennis. She'll be talking about the mythology of Aquarius, which gives this meteor shower its name. So stay tuned.
Hello, and welcome to our coverage of the Delta Aquariid Meteor Shower here at Slooh. My name is Trisha Ennis, and I am the mythology expert here. And once again, we are looking up at the night sky, waiting and watching for shooting stars. As with all meteor showers, this one takes its name from a constellation. In this case, Aquarius, the water bearer. As with the vast majority of constellations, Aquarius is primarily inspired by Greek myth. And as with nearly all the myths of the ancient Olympians, this one revolves around Zeus. In the city of Troy, there was a beautiful young prince named Ganymede. You might recognize Ganymede as the name of one of the moons of Jupiter, and this story is why. Not only was Ganymede considered the most beautiful person in all of Troy, he was considered the most beautiful of all mortals. One day, he was in the fields tending to his father's sheep on Mount Ida when he caught the eye of Zeus, the king of Mount Olympus and ruler of the skies. Now, when Zeus takes a liking to you, you don't really have much of a choice in the course of your life. Zeus had a history of swooping down from Olympus and taking the form of something or someone else in order to endear himself to the object of his affections. I've previously told stories about Zeus taking on the form of a swan to seduce Leda, or even his own daughter Artemis to seduce Callisto. This time, Zeus took the form of an eagle, flying down from Mount Olympus and snatching the young prince up in his talons, flying him back up to Olympus. Zeus would force Ganymede to become the cupbearer to the gods, tasked with bringing wine, ambrosia, and water whenever Zeus or his fellow Olympians called for it. In exchange for taking his son, Zeus gave Ganymede's father a herd of the finest horses, which was apparently enough to please the Trojan king. After some time, Ganymede, though, grew tired of his life of servitude. In an act of defiance, he took all the stores of wine, water, and ambrosia and poured them out. They cascaded down from Mount Olympus and flooded the rivers and oceans of the world, covering the planet. Zeus was furious and wanted to punish Ganymede for his actions. But in a moment that was very out of character for him, he decided to have mercy on the boy. Instead of punishing him, Zeus decided to make Ganymede immortal and place him among the stars as the constellation Aquarius, the constellation from which tonight's meteors seem to stream.
We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at slooh.com. Space is limited. And we welcome you back to our coverage of the Delta Aquariid Meteor Shower. We've been watching this shower for 2 hours and 45 minutes, and we've seen one meteor, but we're lucky to have these great feeds from all over the world with beautiful views tonight, plus our Slooh Observatory feeds coming to us from the Canary Islands and Chile, which are at our special certified dark sky sites. Well, we have learned an awful lot about meteors, how people have felt about them, how we can photograph and listen to them. And if you missed any of our segments tonight, don't worry about it, because we're going to continue to replay them as we watch for meteors throughout the evening. And again, as we go through the night, closer we get to dawn hours through all over the world, really, that enhances our chances of seeing meteors. So hang in there. Coming up next tonight, it is Slooh astronomer Bob Berman again to tell us about meteors, what they are, why they show up, and why meteor showers happen. And that's all coming up next, right here on Slooh. So stay tuned.
Hey, this is Slooh. I'm Bob Berman, and we're here to explore meteors. Well, we're watching them. It's so cool, with special low-light equipment as they're zooming across the sky. So let's explore what it is that's happening. First of all, a meteor. What is it? A lot of people don't realize that a meteor is just the name for anything that's whizzing into our atmosphere, coming in from outer space. It could be anything. Piece of an asteroid, piece of a comet, a chunk of a planet even, and that has happened. It could be your grandmother coming in from outer space. Anything is called a meteor. And if it makes it through the atmosphere, and very few do, if it survives its trip, its fiery trip through the air, typically at 20 miles a second, or even faster, and it's found, then it's called a meteorite. so its name changes. It even has a different name before it hits the atmosphere. Then it's a meteoroid. So whatever might slam into the International Space Station would be a meteoroid. If it reaches the atmosphere and therefore starts to glow so that you see it as a streak, in other words, a shooting star or a falling star, then it's a meteor. And if it reaches the ground and you can pick it up, it's a meteorite. Now, as to what that is, tonight we're watching a meteor shower, and meteor showers are almost always comet fragments, which are kind of fragile, icy objects that do not survive their passage through the atmosphere. Of the 50,000 meteorites in collections that are known about on Earth, exactly 0 are pieces of comets. None from meteor showers. So almost all of them are asteroid fragments, all but about 100. There's 100 that are pieces of the Moon or Mars, or in one case from the asteroid Vesta, where we know exactly what asteroid it came from. Most of them are chunks of asteroids that have collided with each other and made smaller and smaller pieces. And the pieces can be anywhere from huge. After all, we've had meteorites in people's collections, some notable cases where they were 10 pounds and almost the size of a bowling ball, or just a little bit smaller than that. That's what happened to Michelle Knapp in 1991 when one came through her car trunk and demolished her 10-year-old Chevy Malibu, or the one in 1982 that crashed through the house in Wethersfield, Connecticut, where Bob and Wanda Donahue had been watching TV, MASH it was, and it came through the roof, knocked over furniture, made a whole bunch of damage, but they told me that their insurance actually did pay for all the damage, believe it or not. So we do get clobbered by meteorites. A house is hit once every year and a half, on average, in North America alone. But these are almost all asteroid fragments, because that's sturdy stuff made of stones and metals. Tonight we're watching a meteor shower, and as I said, these are icy materials that don't make it through the atmosphere. Their sizes can be anything from tiny apple seed specks, and then they produce a quick streak that vanishes. You're not actually seeing the meteoroid itself when the meteor is streaking across the sky. That's not what we're seeing. We're not actually seeing an object 60 miles away, and they are all between 60 and 100 miles away. Lower than 60 and they've burnt up or stopped glowing. Higher than 100 and the air hasn't yet made them start to glow. So they're all between 60 and 100 miles away, which means pretty much over your head. You can't see over the horizon very much, so you're not going, if you're in, let's say, the Boston area, you will not see a meteor over Chicago. It's a local event. So most of them are really tiny. Occasionally you'll get one as big as a raisin, and then it'll be really brilliant in the sky. And should something as big as a grape come through, boy, that's going to light up the sky and cast shadows on the ground. So they're mostly quite small. And you're not seeing the object itself. You're seeing the air around it that's been heated to fluorescence. After all, these things are all coming in at least 10 miles per second, and many of them at 30 or 40 miles per second. It varies with the meteor shower. Each meteor shower has particular speeds, and at that kind of speed, it heats up the air. In other words, ionizes the air, and you're seeing the glowing air surrounding the little chunk of stone or ice. You're not seeing the actual object itself. Now, if it should turn into a meteorite and be found, we know where it's from because of the isotopic ratio, mostly oxygen. See, oxygen comes in 3 varieties. Most of the kind that we have that we're breathing right now is O16. 16 because it has 16 nucleons, 8 protons, 8 neutrons. But there is a form of oxygen, and we're talking about only a few parts per million, that have extra neutrons. They always still have 8 protons, otherwise they wouldn't be oxygen. That's what defines oxygen, having 8 protons. But if instead of 8 neutrons you have 9, have an extra one, then you have 17 nucleons, and that's O17. And there's even something called O18. Now, in different worlds, like Mars, let's say, there's a different ratio of O17 and O18 to O16. So if you find a specimen and you analyze the oxygen isotope ratio, it's a fingerprint for where that thing came from. So that's why we know whether it came from another world or not. Oddly enough, our moon has material, oxygen on it, with almost exactly the same isotope ratio as Earth, which shows that it once was part of Earth. In fact, it's a little weird because it's believed that the moon formed from a Mars-sized body that hit Earth, and pieces of both Earth and this other object formed the moon. But if so, that other object should have had a very different isotope ratio, and the moon doesn't have a significantly different isotope ratio. It seems to just be part of Earth itself. So that's weird. That's a mystery that still has not been solved. Anyway, it shows you that meteors really can give you information about the universe at large and other objects in the universe. Now, any night you're going to see about 6 shooting stars, 6 meteors per hour, especially after midnight. And the reason why midnight is so important is because at that hour, your rotating position on Earth has moved you into the driver's seat. You're facing forward. See, as Earth goes around the sun at about 18.5 miles per second, there's of course a leading side and a trailing side. Before midnight, you're on the backside of Earth. You're looking into space where we've come from. You're looking backwards in the rear view mirror. But after midnight, you're starting to rotate into the forward side of Earth, and at dawn, the exact look-ahead direction is high overhead, or at least way up in the southern sky. So, of course, after midnight, and especially when you get toward dawn, you're in a position on Earth where you're slamming into meteors. They don't just have to catch up to you from behind, but they're hitting you head on. So, of course, you're going to see more. Now, any night from midnight to dawn, you'll see about 6 an hour, and those are called sporadics. Sporadics mean they're from anywhere. They're stray material in their own orbits around the sun. They could have any size, they could have any speed, moving in any direction, and they do. But meteor showers like the one tonight, that's different because all the debris came from a particular comet with a particular orbit, and they also tend to have fallen off with a pretty narrow range of particle size. And that's why all the meteors we see tonight, there's not a huge range in their brightness. Some are brighter, some are dimmer. Generally in meteor showers, by and large, many are medium brighter, many are brighter, or most are faint. But there is a certain range. There's no range in the direction and the speed. They all come from one part of the sky, and they're all moving at the same speed relative to Earth. And that's what characterizes a meteor shower. But again, 6 an hour are sporadic. So as we watch tonight here at Slooh, let's see if you can tell which are the sporadics. You'll see the meteor shower members all coming, zipping from one general direction, as if they're radiating from one spot drilled in the heavens. And the sporadics are different, coming from other directions. So it's kind of fun to pick out which are the sporadics and which are the regular meteors. It's one of the nice activities to do during a meteor shower. It's one of the things that makes it so much fun. And so, several times a year, and for some reason, defying the laws of chance, there are more meteor showers between August and early January, when the quadrantids are active. That's the meteor time, whereas from early January until August, which is most of the year, there are much fewer background meteors, sporadics, and far fewer meteor showers, and the meteor showers that are around are just weak and wimpy. So it's really cool, like they're concentrated in one part of the year. So those are all the meteor basics, and with that in our pockets, let's just keep enjoying this as we watch these shooting stars here at Slooh. For Slooh, I'm Bob Berman. Hey, this is Slooh.
We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at slooh.com. Space is limited. And we welcome you back as we continue our coverage of the Delta Aquariid Meteor Shower tonight. And it's my pleasure to welcome Paul Cox back to the show. And Paul, we got some big news, my friend. We have another meteor sighting. And it is not from the southern hemisphere, it's from the northern hemisphere. Let's check it out right now. Sullivan, Illinois.
Excellent. And that is such a telltale meteor in one of these all-sky cameras. So in reality, this happened in an absolute instance. But there we can see it. It's even got some color. And a lot of meteors that you see do give a colored trail afterwards. But you can see very distinctly there, Jerry, that one end of it is bigger than the other end, and that's because it gradually burns up as it's coming in. I mean, it's coming in at about 90,000 miles an hour or something ridiculous. So it starts to burn up in the very upper atmosphere, 60 miles up or something like that, and then that intensity gets greater and greater. Remember, this is only a particle the size of a grain of sand, but the kind of explosion as this thing's being atomized just gets larger and larger, and then it's snuffed out. But with these Delta Aquariids, if you had been at that site watching that with your own eyes, chances are you would have seen this persistent train that some of our experts have talked about tonight. This is a kind of a little stream of ionized gas, and it can stay there for anything up to 30 seconds on some really large meteors. But these ones in particular, Delta Aquariids, they do tend to leave some of these trains. That is also actually what our radio detection system does. When we've been listening to meteors tonight, it is those radio waves which is bouncing off those ionized trails that we're hearing, the reflection of those radio waves.
Now, this particular image, Paul, comes to us from an observatory in Illinois. This is not one of our Slooh observatories. So why don't you explain to the people watching the program how it is we're able to monitor a feed that's not our own?
Well, it is our dedicated team who are in Slooh HQ in Washington, in Connecticut. And I'm not actually in the studio tonight with them, but we've got our studio team there. We've got Laura, we've got Carson, we've got Cara looking after our social channels over there tonight. And actually, Laura is in the chair. She's the person controlling us on the screen here at the moment. And I think they'll have to correct me if I'm wrong, but I got a sneaking suspicion that so far the score in the studio is 2 to Laura and 0 to everybody else.
Doing yeoman's or women's work tonight in the studio at Slooh headquarters. All right, Paul, thanks a lot. Go rest up for the final hour, and we'll get you back to you soon. Okay. By the way, we've been getting some great interaction on our social media feeds tonight. So a big hello to everyone watching on Facebook and commenting on our feeds. We've also been monitoring our Twitter feed today, and we got a question from Anne Branagh. I hope that's how you pronounce it, Branagh. Branagh, asking us who the author was of the poem in our art and culture section. That poem was Shooting Star by Arthur Z. Shooting Star by Arthur Z. You can ask any of your questions or comment on our show tonight by tweeting us with the hashtag Slooh. We would love to hear from you. That last segment also reminded me of what great plans we have for the rest of the summer here at Slooh, with our most exciting event ever coming up in less than a month. We're going to be heading out to Stanley, Idaho for the transcontinental total solar eclipse this year, getting ready for that big road trip, and any astronomer or apprentice Slooh member can join us and have a whole lot of fun for free. It'll be great fun on that campsite. And there's a lot more to it than just camping out, believe me, as you've heard tonight from our friend Paul Cox, getting prepared for his trip out there right now. He's been on with us a few times through the night to talk to us about it, along with other exciting things that Slooh and all of our members have been up to. He'll be on again in just a little while to chat with us again and bring us up to speed. All right. Coming up next, we've got a segment from astronomer and journalist Will Gator talking about all the ins and outs of how to photograph meteors, what kind of conditions and equipment you'll need to snap your very own pictures. So you'll want to stay tuned for that. We'll be right back.
Hi, my name's Will Gator, and thanks for tuning in to our live coverage here on Slooh.com. Now, if you've been looking at some of our live feeds on the screen, you might have been thinking, oh, I'd really love to try and capture a picture of a meteor tonight as the meteor shower reaches its peak. Well, now's obviously a great time to try because there'll be a lot more meteors than usual in the sky, but there are also lots of other things you need to do to try and do this. And in fact, meteor photography is really quite difficult. You can take hundreds of pictures and really only capture a handful, maybe one or two meteors on camera. So how do you do it? Well, In my experience, the best type of camera for imaging meteors is a digital single lens reflex camera, or a DSLR. And this is because they're particularly sensitive, and you can also use them with very wide angle lenses. And wide angle lenses allow you, of course, to capture a large section of the night sky. Now, there are other types of cameras, certainly some of the modern mirrorless cameras and bridge cameras. They can actually take very sensitive wide field images of the sky. They can use interchangeable lenses as well. But in my experiences, I tend to use a DSLR camera. So what you need to do is basically set up a DSLR on a tripod. That tripod will keep your camera very still, stop any vibrations, and that's crucial because in order to capture a picture of a meteor, you need to make sure that your shutter is open for a fairly long period of time, so perhaps 10 to 30 seconds at a time, and keep the camera firing almost continuously. So in order to do this, one of the things you might find very useful is to have a remote release handset. Basically, you have this set continuously firing in continuous mode. So in modern DSLR cameras like the Canon range of EOS cameras, you actually have a mode that allows for continuous shooting, and so this allows you to take continuous exposures of say 10 to 30 seconds, and hopefully during that time a meteor will flit across your field of view. Now, as I said earlier, the wide angle lenses are the best type of lenses to use really. You don't want to go too wide, because if you have something like a fisheye lens, then even the faint meteors, they won't really show up very well. But maybe a focal length of perhaps somewhere in the region between 14 millimeters and say 20 millimeters is probably ideal for something like a full format, a full frame digital camera. So that's the sort of thing in terms of lenses. And where to point your camera in the sky? Well, this is always a tricky one because, of course, you don't know, we just can't predict when meteors will appear in the sky. But I've found that typically, you know, if you want long trails going across your images, around about 45 to 90 degrees away from the radiant, those are good places, because if you point your camera too close to the radiant, you'll only get very short, stubby trails of meteors because of the perspective effect that we see of the meteor trails in that part of the sky. And if you point your camera far away from the radiant, generally you will find that you get much longer trails there. So that's something to consider. Now, what about things like the ISO sensitivity setting on your camera? Well, in this respect, meteor photography, you kind of have to make certain sacrifices over, say, the quality, the fidelity of an image. And I find that actually you really have to push the ISO setting up quite high. In some cases, 1600 to 3200 ISO are the sort of settings, and that might mean that your images are slightly grainy. You might get that chromiance noise, that sort of coloured blotching on camera, but it does mean that if there is a faint meteor that goes across your field of view, you're much more likely to pick it up. So don't worry too much about the quality of your image, because of course, you know, what you're trying to do is capture a meteor. So hopefully, if you use all these tips, you might be able to capture a meteor on camera, but it is just luck. I said earlier on that you can take hundreds of frames and only in a few meteors might appear in one or two of those, and that's true. Certainly I've been shooting some of the very, very particularly strong meteor shower peaks, like for example the Geminids in December and even the Perseids in the summer, and I've only caught a handful in a whole night's worth of imaging. Now, of course, if you're lucky enough to own two cameras, then you can put one camera on one side of the sky and another on the other, and that certainly increases your likelihood of seeing something. But what about the sort of processing side of things? Well, one of the cool things you can do is if you carefully take your images into a program such as Photoshop or something like that, you can start to overlay some of the meteor images, and you can find and locate where the meteors are in different parts of the sky, and then you can build a composite to show where the radiant is in the sky. So you can actually put the images together, put the trails into their respective parts of the night sky on a single image, and then you can actually get this view, this sort of star warping view where the meteors all appear to be coming from the radiant, like of course they are in real life. So you can create some really interesting creative images if you take them and process them in a clever way. But as I say, don't worry too much if you don't capture something on film, because it is really down to luck of where those good meteors will appear. But if you get a bright fireball go through your field of view, it can really make your night. So good luck photographing the meteors, and of course, if you don't capture any on film, keep an eye on Slooh.com, where we'll have pictures from our live show and our live feeds here. So good luck, and I wish you all the best for your meteor photography tonight.
We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at slooh.com. Space is limited. And we are back as we continue to keep tabs on the Delta Aquariids Meteor Shower tonight. We've been watching all of our feeds for just over 3 hours now. And even though this isn't one of the more active meteor showers of the year, we've seen a couple. We are keeping track of any we do catch with our telescopes and others around the world. And back to talk about those telescopes and what Slooh has to offer is Paul Cox. So, Paul, once again, let's go through the feeds we have set up tonight.
Yeah, well, let's start with this one, which is my favorite of the night. We can see the sky's a little bit red here. We'll see why in a moment, but this is our new constellation cam. This actually has the widest field of view of any of the telescope systems that Slooh members can control. It's about 25 degrees across, and that's why it's called the constellation cam, because you can capture even the largest constellations in there. And that's what's going to be, I think, probably the most popular pastime with this new telescope. It actually sits on top of a larger new telescope, which is generating unrivaled views of some of the best summer treasures, some of the best galaxies and nebulae to see at this time of year. But we're here to talk about meteors. So if we take a look at our all-sky camera tonight, you will see why the sky is looking a little bit red in that last image. Look at this. I mean, this haze and dust, Jerry, was thick when we started off this 4-hour marathon, but my goodness, this is getting really, really thick now. So this is even getting to the point where it would be difficult. It would blot out some of the faintest meteors in here. But the good news is, if viewers have stuck with us this far, remain with us for the next 35 minutes or so, because this is now the peak time in the hour or so before dawn. That's when you see most Delta Aquariid meteors. So this is going to be a good one to watch. We're going to keep a good close eye as well on that constellation cam. But we've also got our live meteor cam itself. And this is providing, this looks a little bit streaked, but it's just the way this particular camera works. It's actually a live video stream. So it's an incredibly sensitive camera. And this one, actually, on past meteor shower shows, this is where we've caught most meteors at this kind of period of the meteor shower. So we should keep an eye on that. Now, in this view, in the other views that we've seen, we'll see a meteor as a line, and it will stay there because those are static images being updated every few seconds. So we'll see that stay there. This is live video. In fact, I'm not sure if I just didn't see something there. In fact, I blinked at look there.
There we go. Oh my God.
Okay. Well,
wow.
That's kind of good enough, isn't it? For you?
On cue.
What I was saying was this camera has provided some of the best feeds we've had on past meteor shows at this stage of the meteor show. So yes, as if by cue. So yes, okay, I think we're a bit pleased by that one, aren't we?
I should say so. Holy mackerel.
So it's kind of made 3.5 hours worth it.
I'd say so. Well, we saw a couple earlier too, Paul, not through our feeds, but through a couple of observatories around the world, one from the southern hemisphere and one from the northern hemisphere.
Yes, and as we said a little bit earlier, this particular meteor shower, the one today, there are actually 2 Delta Aquariid meteor showers actually, and today's one is called the Southern Delta Aquariids, and then later on in August it's the Northern Delta Aquariids. So this one is better seen the further south you are, but it doesn't mean that even if you're far north, as we've seen, you can still see these. It's just you to see more in southerly latitudes. And of course, the Canary Islands is kind of in the middle. It's certainly lower down than, the majority of the United States, or certainly the rest of Europe is further south. So it's pretty well based for this particular meteor shower. Then now I can't take my eyes off this feed because I don't want
I
to miss
know, me
another
too.
one.
That was almost unreal. So, Paul, let's talk about Slooh members. What have they been up to lately? Any recent discoveries?
Oh, yes, we have. We've had a couple of good discoveries recently. I mean, first of all, there was an asteroid discovery by one of our European members, Goran. And you can always spot his missions. He's always hunting for asteroids, and he does this big search. And there it is, whizzing across the sky. I wonder if that's Goran's one or whether that is a later one by Tony Evans, that may have been. But anyway, there it is. But it's not only an asteroid discovery that we've also had a nova discovery by Slooh member Emmanuel Conseil. Now, he's another European who's based in France. Who'd have believed it, with a name like Emmanuel Conseil. And Emmanuel, this is not his first discovery with Slooh, but every time I see it, I'm just more and more amazed by his tenacity. What we're looking at here is a section of the Andromeda Galaxy. So the core of the galaxy is down to our right. It's off this image. There are two little red tick marks just to the left of you, Jerry, on this image. And it's highlighting not the two bright stars that we see there, but a really faint star that you really have to look at hard to see. And that is the nova that Emmanuel has spotted in this image. And this is a zoomed in version of this image. You know, you see the full image and it's massive. And Emmanuel manages to spot, I mean, he's got a little bit of software that helps him, but he manages to spot these tiny exploding stars, and that was one of them. But he can't just then say, whoa, I've discovered a nova, you know, give me praise. It's not confirmed because all manner of things could cause a little white spot like that. A cosmic ray hit maybe to the camera or the telescope will cause exactly that. So he has to wait, he has to be patient. He needs to jump back on the Slooh telescope and reserve another mission to that exact same spot. And if he sees exactly the same small white dot in exactly the same position, he knows it's not a transitory object. It's not an asteroid crossing the field. It's not one of these hot pixels or anything like this. It's a discovery. But then he has to report it. Because in astronomy terms, it's not the first person who sees something. It's the first person who reports it. And Slooh members have been pretty darn unlucky in that respect because they have been this first to actually witness live supernovas going off in distant galaxies. But the problem is nobody recognized it as a supernova, so nobody reported it. Somebody else has then reported it, and they get credited with that discovery. You know, so Emmanuel, as soon as this is the first thing he does in the morning. So he's going to check his Slooh images that will say, because he's in Europe, you know, the Canary Islands telescopes are operating while he's in bed trying to get some sleep. He gets up in the morning, probably with his large mug of French coffee and his, you know, baguette there. Sorry, that's a bit of a stereotype, I know, but that's probably that's what I would do if I was in France anyway. And he checks his Slooh images for these tiny transient objects, and he has discovered a whole stack of these and supernovae, and he also uses the Slooh telescopes to make confirmation images from other people around the world, because they know that Emmanuel is a Slooh member. They know that he can turn the half-meter telescope to any object in the sky at really short notice. So if they've taken an image and they've got a suspect supernova or nova or comet even discovery, then they get hold of him. Emmanuel takes an image of that part of the sky, and you have to do this with people that you trust. Because if you just went out onto social platforms and said, hey, listen, I think I've discovered a comet, can everybody check these coordinates? Anybody unscrupulous will just take an image of it, report it, they get credited. So you get Comet Cox, not Comet Monteau. Don't trust me, Jerry. I want that comet discovery. Don't trust me.
Yeah, I trust, believe me. I almost said, trust me, I don't trust you. But believe me, no one trusts you. We know better. All right, listen, we're going to check back with you shortly. We got about another half an hour to go in this program. So stay with us, Paul. Don't go anywhere. In the meantime, folks, up next, we've got Slooh astronomer Bob Berman talking us through the whys and wherefores of the Delta Aquariids, and just the kind of meteor shower that this is compared to others that happen throughout the year. So stay tuned.
And check these out. It's very special in a number of ways. First of all, Aquariids, what does that mean? It comes from Aquarius. All of the other meteor showers are named for the place where the radiant is located. All shooting stars seem to radiate away from some spot in the sky, and the constellation that that's in gives the meteor shower its name. We use the Latin possessive form. In most cases, it sounds pretty much like the constellation name. That's why we get the Perseids from Perseus, the Geminids, whoa, tremendous shower every December 13th to 14th. That sounds like Gemini, but Aquarius, going from Aquarius, where the accent is on the second syllable, to the Aquariids, accent on the first syllable, that's a little bit of a jump. Anyway, that's where it comes from. This is the Delta Aquariids, named for a faint star that you'd never notice in a million years, popularly known as SCAT, S-K-A-T. Nobody even calls it that, because no one looks in that direction. This is a southerly part of the constellation, and Aquarius to begin with is a very rambling, spread out, hard to define constellation. Of all the 13 zodiacal shapes, and I'm including Ophiuchus, because the sun and the moon and the planets spend more time each month or each year passing through Ophiuchus than even Scorpius or Libra or the others. But of all of them, this is the least definable. Not that they all look like what they're supposed to. Capricornus doesn't look like a sea goat, whatever that is. It looks more like a map of New York State, sort of a triangle. And many of the others similarly look obscure, but at least you can pick out the shape of the stars. But Aquarius is not like that. It just spreads all over the place. So this comes from the southern part of that. And if you want to watch tonight, in addition to viewing the meteors here at Slooh, and you go out and look for them, you'll see them zooming up from the south. And that's very different from the Perseids, which come from the north. Perseus is a northern constellation, so a quick way to tell the difference is that if a meteor is traveling very fast and coming from the northeast or north, that's a Perseid. And if it's zooming from the south, generally slower and fainter, that's more likely to be a Delta Aquariid. In fact, it comes all the way from near the star Fomalhaut, one of the loneliest stars in the heavens. Interesting star, spectral class A, very similar to Vega, a much more famous overhead star for North American observers and European observers. Fomalhaut sits more isolated than any other first magnitude star. Same spectral class, same distance even, 25 light years away. But because it's low for people in Canada and the U.S. and Japan, and it's rarely observed, at least not as much. Another way to find the radiant for this meteor shower is to follow the right side of the Great Square of Pegasus. The two stars on the right, just follow them down, down, down to the south. That'll take you to Fomalhaut, and they'll take you to where these meteors seem to zoom away from. They zoom at 26 miles per second. Now, that's medium fast. They're not as slow as the Geminids seen in December, and they're certainly not as fast as the blazing hot Perseids in August, or the Lyrids either, both of which come into our atmosphere at close to 40 miles per second. So these are noticeably slower, and that may be one reason they leave fewer persistent trains. Yep, that's the term for a trail behind a meteor. About 1 in 3 Perseids leave a glowing train, like a Cheshire cat smile, just lingers in the sky for a few seconds after the meteor has burned up and gone to meteor heaven. But in this case, the Eta Aquariids, only about 1 in 10 to 1 in 20 leave behind glowing trains, so they're a little bit less spectacular to see. And on top of that, they're fainter in terms of producing fewer fireballs, really, really bright specimens. So they're more of a challenge, but what the heck, we thought we'd throw them at you this year and observe them tonight, and, our equipment keeps getting better in detecting meteors going across the sky. Every meteor shower really pieces from a comet, I guess, except for the Geminids, whose parent body is a strange object called Phaethon, and it's more of an asteroid than a comet. We're starting to think that sometimes when comets get all used up and their ices have been depleted from repeated passages near the sun, what's left, the little core that's left, can look like an asteroid. So that's the case for that meteor shower. All the others really are bits of comet material, and in some cases famous comets, such as Halley's Comet. The Perseids coming up are the result of the comet Swift-Tuttle, discovered by Civil War astronomers Lewis Swift and Horace Tuttle. In this case, it had not been clear what the parent body is, and even to this day, it's not 100% certain. It seems likeliest that it's part of a comet named 96P, Comet Machholz, named for Don Machholz, who's a very prolific comet discoverer. Some say the most prolific of all naked-eye comets. We have Australian comet discoverer Robert McNaught, who certainly found more comets than anyone else, but most of his comets were not naked-eye objects. Anyway, Don Machholz, and I'm not sure I'm pronouncing his name correctly. Only the owner of a name is the authority on how it's pronounced. I've never met him. Is it Machholz? Machholz? I don't know. I'm not sure. But that's the comet. He discovered it with 5-inch binoculars, giant binoculars, back in 1986, even though the comet's name is from 96, because that's when it was seen and its orbit determined, and that seems to have the same orbit as these objects, and a strange orbit it is. This is one of the weirdest comets. In fact, it's so weird. Let's talk about that in a separate segment, because we're seeing fragments of an object that may be among the strangest that ever zoom through the sky. Meantime, we'll keep watching. Again, a bit challenging because there are not as many. Typically, you'll see something in the order of 16 of these per hour. Now, compare that to the 60 to 100 meteors per hour that we get with the Perseids, and the 100 per hour that we pretty reliably get with December's Geminid shower. And you can see this is at best maybe only 1/5 the rate of those others, even when they're at their skimpiest. So fewer of them, they tend to be fainter, there's fewer fireballs. Why the heck are we even doing this? Because, first of all, there will be Perseids that we're going to see as well, because both of these showers, this one, the Delta Aquariids and the Perseids, go across the sky for a long period of time, from late July right until mid to late August. True, they have peaks. The peak of tonight's shower here for the Delta Aquariids is tonight. Peak for the Perseids is usually August 12th. But nonetheless, they're seen all these nights. So they're there. They're up there. And
We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at slooh.com. Space is limited. And welcome back once again to Slooh as we wrap up our Delta Aquariid Meteor Shower show coverage for this evening. We've had some great views tonight. And Paul Cox, welcome back to the program. In the last hour, things really started to pick up nicely. And you said it was going to get more active the longer we waited, but I wasn't ready for this.
It was pretty well timed, wasn't it? We were saying that, like most meteor showers, it's in the couple of hours before dawn, and then that happened for us. I mean,
Look,
that is an absolutely classic meteor. It's absolutely stunning. I mean, that's almost verging on fireball stuff.
that was absolutely incredible. And you had an inkling that something was about to happen, didn't you?
Well, I'm pretty sure I saw something the split second before it. But actually, when the studio had been looking just after we went off the last segment, we caught something just after it as well. But we're going to examine this video very carefully in the morning and see whether or not there was anything else that was going on. But I mean, the lovely thing with this one, Jerry, is it's such a large meteor that we can actually see some structure in the trail. So when you see it starts off small, that's when this speck, this is probably the size of a small pebble, is hitting the upper atmosphere. So that's when it starts to heat up, starts to burn up. But then if you look at when in that bright section, there's two really kind of bloated little areas. It's like it's got two heads. And that's probably when this little object kind of started to disintegrate. So suddenly you get a lot of vaporization. Then it carried on a little bit further and then another vaporization. So that is an absolute classic, I have to say.
Well, I was anticipating our best views would come from the constellation cam, but it turns out the
Yes.
meteor cam was the go-to camera tonight.
It is, but the problem is that the constellation cam gives us the widest field of view. So it actually gives us the greatest chance of seeing one. But because of the field of view, it's actually going to appear quite small. And because it's taking long exposures, it's going to appear static. Whereas our meteor cam has a far smaller field of view. But as we've seen, when you do catch them, you really catch them. And, even in the 15 minutes, we were all, you, I, the guys in the studio, we were pinned to this view and we saw a few more far, far smaller, far more normal meteors, actually. And it kind of put in context just how big that one was.
Well, as I like to say, it was well worth the wait, Paul. And great work tonight, everybody at Slooh headquarters as well. It's been a long show, but it was again well worth it in the end, Paul. Thank you so much. Well, this wasn't a terribly active meteor shower, and we weren't expecting it to be. But coming up in the second week of August, we have the big meteor show of the summer. It's the Perseid Meteor Shower, and that one promises to be much more active, and we always get some great shots from that with our Slooh feeds and all of our partners. So be sure to join us for that one on August 13th. By the way, you at home can always be involved with astronomy here at Slooh. We have an amazing community from all over the world with all kinds of interests. So no matter which segment you heard tonight was your favorite, there is something for you in our Slooh community. We have artists, authors, and scientists alike, and we'd love to have you too. So if you're watching on Facebook tonight, be sure to head over to slooh.com to check out everything you can do here, including controlling some of those telescopes that Paul talked about earlier on in our show, or contributing your own content to our community. Also, exciting on Slooh, our upcoming trip to Stanley, Idaho for the transcontinental total solar eclipse. If you haven't made your own eclipse plans yet, Slooh apprentice and astronomer members can join us in Idaho for our Eclipse Festival. starting Friday, August 18th and running until Tuesday, August 22nd. We're inviting all Slooh members to join us in Stanley, Idaho for a weekend of fun, science, music, and more at our reserved campsite. And the best part, it's completely free to all members of Slooh.com. So it is finally time to say goodnight. We hope you enjoyed our show. It's the Delta Aquariid Meteor Shower. We do this all the time here, so be sure to catch our next show on Slooh.com. Before we say goodnight, keep your eyes on our meteor cam, because that's been the go-to camera tonight for meteors here as the evening progresses. So thanks for stopping by. I'm Jerry Monta. You've been watching Slooh, your interface to outer space.
Thank you.